So today we're going to look at the midpoint of a line segment in analytical geometry. And a midpoint is halfway between two given points. So if you had A 2, 1 and B 8, 3, the midpoint of the line segment would be somewhere in the middle. So let's put it there for now. So AM would be the same length as MB. Okay, so to find the midpoint, we need to obviously find the middle of the x's, because that would give you what the x coordinate is, and the middle of the y's, and that would give you the y coordinate of the midpoint. So it's like finding the average or the mean of the x's and the mean of the y's. So here's our formula that we use for finding the midpoint. The x at the midpoint, x at m, we add the x's on the two ends, so the x at a plus the x at b, and we divide everything by 2. And to find the y of the midpoint, we add the y's together, the y at a, the y at b, and we divide it by 2. So let's try an example. All right, so we're going to find the midpoint of this line segment here. Okay, so the x at m, we said, is add the ends together. So the x at a plus the x at b divided by 2. All right, so the x at a is a 2. The x at b is an 8. Obviously, we do this numerator first. It's like an invisible bracket there. So 2 plus 8 is 10 divided by 2. So the x at m is going to be equal to 5. Right, and then we go and we work out the y at the midpoint. So the y at a plus the y at b divided by 2. The y at a is a 1. The y at b is a 3. 4 over 2, which gives me the y at the midpoint is 2. So then I finish by saying the coordinates of the midpoint are 5 and 2. And if we look at the diagram, we kind of guess where it was going to be. And yes, it looks like the x coordinate is 5 and the y coordinate is 2. All right, here's another example. We want to find n. So somewhere there. N, the midpoint of CD. Okay, so we could count it, but we're going to use our formula. So the x at n is equal to the x at c plus the x at d, add the n's together and divide it by 2. And the y at n is equal to the y at c plus the y at d over 2. Okay, so what is the coordinate of this midpoint? Well, the x at c is -5. Here it is, -5 up there. And the x at d is a -1. So we put that in a bracket so we don't have two signs next to each other. And we divide it by 2. Okay, so that's going to be -5. Positive and a negative give me a -1. So that's -6 over 2, which is equal to -3. All right, then we try the other one. Y at n. So the y at c plus the y at d, the 6 plus the 2. Okay, so the y at n is going to be 8 over 2. Y at n is 4. So it looks like the coordinates of the midpoint should be -3 and 4. And then go check that that's a feasible answer. So if you have a diagram, which you normally do with analytical geometry, we look at the -3 and the 4, and we check, would -3 and 4 be a feasible answer? And yes, it would. We can see that it's quite possible that the x would be -3 and the y would be a 4 to get the coordinates of n. All right, so finding the midpoint is reasonably straightforward. We're now going to look at working it backwards. So if you have the midpoint, we're going to try and find the n coordinates. Okay, so find the coordinates of B if M is a midpoint of AB. All right, so it works exactly the same. We're using the same formula because we've got the midpoint. All right, so we use that the x at M is equal to the x at A plus the x at B divided by 2. And then you fill in what you know. So what do we know? Well, we know that the x value at M is a 6. So we can put the 6 into the x value of M. Do we have the x value at A? Yes, we do. Just quickly write here. So this is the x at A, the y at A, the x at M, the y at M, and the x at B and the y at B. Okay, so x at M is 6, x at A is 2. We don't know what the x at B is, so I'm going to write xb there, and we're going to divide it by 2. All right, now this is an equation, and you're going to solve it. All right, and we're solving for the x at B. So the first thing with this equation is there's one term on each side. So we're going to times each side by 2. Okay, and this will always be like this because there'll always be a 2 in this formula. So we're going to take the equation, we're going to times this side by 2, and we're going to times this side by 2. All right, so 12 is going to be equal to, and that 2 would obviously cancel. 2 plus x at B. Now there are 2 terms. So we have to add or subtract. Okay, so because we've got 2 terms on this side, we need to add or subtract to get the x of B alone, and we're going to end up subtracting that 2 to get the x at B alone, and 10 is going to be the x at B. Right, and then you do the same with the y's. So we would start with the y at the midpoint is the y at A plus the y at B divided by 2. What do we know? Well, we know that the y at M is 4. The y at A is 7. We don't know the y at B, and we're dividing it by 2. Now this is exactly the same. So we filled in what we know. We've got an equation, so we're going to solve it. So we're going to times both sides by 2. And we're going to end up with 8 is equal to 7 plus the y at B. And then we're down to 2 terms, just like we were on that side. So we would get rid of the 7 by subtracting the 7, because it's a positive 7. So we're using inverse operations. So 1 is going to be equal to the y at B. So that tells me that the coordinates of B are going to be 10 with 1. And please check if they're feasible. On your diagram, go back and see the x at B could very possibly be 10 because that's 6 in the middle. So that's at least further along the x-axis. And the y at B, well, those are going down, so 1 is a feasible coordinate. So just look at your diagram and see if they're feasible. All right, so your x and your y's are the same steps. Fill in what you know, solve your equation by multiplying by 2 and then either adding or subtracting to get your value alone. All right, so let's just try one more. This is a little bit different. Find the value of x and y if M is a midpoint of A and B. So even if your diagram is just a line, it just helps you to see your midpoint and your ends. Okay, just shows you where we're working. Okay, so we've got the x at A, the y at A. Sorry, that was a really bad A. The x at M, the y at M, the x at B, and the y at B. Okay, so we've got those points. All right, so we need the formula. What formula? Well, this one is a midpoint. Yesterday, or the day before, we were using distance formulas. This is, we're talking about a midpoint. So the x at the midpoint is the x at A plus the x at B. Those are the ends divided by 2. The y at the midpoint is the y at A plus the y at B over 2. Okay. Fill in the given information. So what do you know? Okay, so I know that the x at M, I've got that, it's 5. X at A, I don't have, there's an x there. X at B is an 8 over 2. Okay, and then again, it's one term on each side like the other example, so we're going to times both sides by 2 to get rid of that 2 at the bottom, like that. So we're going to have 10 is equal to x plus 8. And again, I'm looking for x alone. It's now 2 terms, so we're going to end up inverse operations. We're going to subtract that 8 to get x alone, and x is going to be equal to 2. All right, so that means the beginning of the line had an x coordinate of 2. Let's look at the other one. What do we have? We have the y at M. It's 2. We have the y at A. We don't have that y at B. It's just got a y there. And again, we need to solve the equation. So because it's one term, we times by 2. So we times this side by 2, and we times this side by 2. So that's going to give me 4 is equal to 1 plus y. And then, because we have 2 terms now, we must add or subtract depending on what we need to do to get that y or the x alone. Okay, there's a positive 1, so again I have to subtract 1 from both sides. So 3 would be equal to the y. Now I can't put this x and y together because they're not an ordered pair. The x belongs in A and the y belongs in B. So we would leave the answer to the question like that.